Cameron Valve Commander platform improves efficiency and performance by enabling operators to verify valve position in real time, mitigate overpressuring valves, eliminate cut wireline, remove workers from the high-pressure zone, digitize a standard workflow to prevent incorrect sequencing, and increase stages per day by more than 10%.
Hello, everyone, and welcome to SPE Live, a Tech Talk. I'm your host today, David Gibson. And on the show today, we've got Cameron, a Schlumberger company, talking to us about remote operations of a frac tree. All right, guys, if this is your first time watching an SPE Live Tech Talk, please let us know in the comment section. Let us know where you're watching from as well. And as always, these are live for a reason. We want to be able to hear your questions. What do you want to be able to learn from this Tech Talk? As a quick reminder, everybody, coming up, we've got the SPE Hydraulic Fracturing Conference. Registration is open, and there is a link in the description of the broadcast. All right, risks are always part of a workplace, and today's wells focus on valves and, role of real-time automation in the progress of making this faster and safer. All right, today on the program to be able to help us learn more about this is Tony Viator. Tony Viator is a domain champion for surface production systems at Cameron, a Schlumberger company. Prior to that, he was involved in the digitization of completion services portfolio. Tony, thank you so much for joining us today.
Yes, sir. Thanks, David. Thanks for having me. Happy to be here.
Now, I've never officially been on a frac site, right? So I have to play just a little dumb here. So I do know that there are tons of valves out on a frac location. How do you guys know which ones are open and which ones are closed at any given time?
So that's a good question. So on a typical frac pad in North America today, you're going to have anywhere from maybe on a small pad, say 30 valves on location to up to 60 valves on some of the bigger locations, and maybe even more than that. And typically the way you know which valves are open or closed, you've either got to have it kind of straight in your head, or you've got to go into the red zone and visually verify at which position the valves are in. Or you can look at this bank of hydraulic power units or accumulators and kind of decipher from those HPUs what position at least your hydraulic valves are in. But it's a very kind of process-oriented thing and not very intuitive. And you know what's going on most of these pads, because nowadays just about every pad is a multi-well pad where they're running SIMOPS. So you've got wireline going into the well at the same time that you're fracking a stage into an adjacent well. So you know, every time you open and close the valves, it's kind of deemed as a high risk due to the potential for maybe accidentally cutting the wireline tool string or shutting in on the frac stage, or possibly even sending frac fluid to the environment. So typically the way that most operators mitigate this risk is through some kind of process control, and largely across the industry, we've adopted this process control called the three-way handshake. So that basically requires 2 or 3 people on location to walk over to these HPUs. And when they get there, this is kind of what they're looking at. So this is how they know which valves are open and which valves are closed. So there's a lot of color coding. A lot of times you see in duct tape and markers. So not very sophisticated. And you can see through this process control and having to come out here and decode these HPUs before you can make a decision on which lever to turn and then signing off on the sheet of paper. You know, that process control is it's sacrificing speed and efficiency for safety and reliability in the operation. Although because it's a process control, oftentimes mistakes still happen. It's still prone to some human error, and you still see instances of cut wireline shutting in on a frac stage. So, just one incident of cut wireline could be anywhere from $250,000 to $1 million lost to the client. You shut in on a frac stage, you could potentially have to scrap every piece of iron all the way up to the pump trucks. So, talking millions of dollars on just one mistake. Just executing this three-way handshake, you're going to generate up to 15 miles of foot traffic across the well site every single day. People walking across the frac site when they really don't need to be. And you're going to spend, by the time this job's over, maybe 20 to 30 hours just walking back and forth, signing off on the handshake. And you're doing all this and still not adequately mitigating all these risks.
So obviously, knowing what's open and closed, there could be a financial benefit to that. I'm absolutely blown away that I'm guessing somebody might accidentally close the wrong valve and shear the wireline cable.
Absolutely, it happens more than it should. More than it should.
Like I said at the beginning of the broadcast, like, I'm completely new to this, so these things are just so obviously to be able to mitigate that risk is important, but even more so to be able to prevent it. Is there a way to be able to like engineer out these problems?
Absolutely. That's exactly the approach we took when we developed our valve commander system. So the way we're able to do that, the thing that we deploy to the location is our digital enablement skid. So this is where we're actually able to acquire all the data from the valve position sensors. So now we're going to deploy position sensors on every valve that's on location, both the manual valves and the actuated valves. So they all tie back into our digital enablement skid. And then we are actually able to communicate back to that skid through our software, HMI, our human machine interface. And that's how we're actually able to operate the valves remotely. So when we deploy this technology, we are actually able to give up to 6 wireless tablets. So typically you don't need 6. Typically you're probably looking at deploying 3. So in other words, that 3-way handshake, all those parties, now they have their own wireless tablet, and now they can all operate and witness the operation of the valves without having to walk across the well site every time to the HPU, eliminating up to 15 miles of foot traffic from the operation every day. So the next piece of software, or the first piece of software that we're going to interact with, this is going to allow us to do, once we actually rig up the frac trees and all the valves on location, we actually go and build and configure the valves on the screen to look the same way they look in the physical world. It's a very intuitive sort of app within the app. It's just a drag and drop. I touch the open, empty green circle, and I say on this location, I'm going to put either a manual valve or an actuated valve or a flow cross or a pressure gauge, whatever item I want to put in the stack exactly as I built it. And it allows me to go through and do a validation sequence where I've confirmed that all the sensors, all the sensor cables and hydraulic lines are now hooked up properly. When I tell the upper master valve to open, I can see it physically open, and I see it open on the screen. Everything's hooked up right now. I'm ready to take control of my assets digitally, right? So this is just a tool that we developed to allow our clients to have unlimited flexibility in their frac tree designs. So once we've done that, now we're ready to start operations. And now you can already see by looking at the screen, how do I know what position my valves are in? So look at the screen now, right? You can see the position of every valve on location. You can see the black well, the obsidian well, is in wireline mode and the well's shut in. And I can see exactly who has control of that well right now. I can see in the purple well, like the well's open for the frac stage, and I can see who has control of that well. Now, say one of the valve techs on location was doing the valve operations for this frac stage, and they're getting ready to do the wireline run. The wireline company man's ready to take control of that well. He can simply come to the home screen. He clicks on the take control button, and now he has the ability to open and close valves. So you can do true SIMOPS. So somebody can be operating the valves on the well for the frac workflow. At the same time, somebody's operating the valves on the well for the wireline workflow, but never two people operating valves on the same well at the same time to prevent any unintentional valve openings, right? So once I'm actually ready to open or close valves on a particular well, I'll click on that well, and it's going to take me into the screen that you see below, where I actually am able to execute my workflow. So in effect, once we get to this screen, what we've done is we've replaced the operating dashboard on the left with the operating dashboard on the right. So there's no more walking over to accumulator banks and decoding which position the levers are in. You can actually see the well. You can see clearly what position every valve is in. In addition to that, we actually work with the client before the job starts, and we get their standard work. So exactly what their workflow are and what sequence the valves need to be open and closed in. And you can see we actually map that workflow into the software. So what you're looking at here is a pretty typical wireline workflow. You're gonna isolate the well, prime up and pressure test your lubricator connection, open the well to make the run, and then shut in the well. And then we give an optional shut-in pump down in case you need to shut the pump down wing in. So for each one of these steps, so as soon as I click and prime up and say I'm ready to prime up the well, I'm going to get an indication on which valves need to be open and which valves need to be closed by this orange band. The one that's blinking with the orange band is going to be the valve that I need to open or close first. So, and that's the only valve that the software is going to allow me to open. So again, it's enforcing that standard work, as opposed to this scenario on the left where somebody could walk up to an HPU and turn any lever at any time. Now you're following standard work instructions that are enforced by the software. You can see clearly the red valves are closed, the green valves are open. When it turns yellow, like the one in the top of the tree, that means it's in transition on its way to being either open or closed. You can also see these hash marks that run through the valves that are perpendicular to the flow path of the tree when the valves close, and they're in line with the flow path when the valves are open. So even someone who can't distinguish between colors can still operate the system. I know I'm speaking fast and saying a lot, so if you have any questions at this point, let me know. If not, I'll just keep on rolling.
Well, we do have a question, and I should say, you know, everybody's trying to get in their steps, but keeping your step count low and not going into the high pressure zone is probably a good thing. So one of the questions that we've got, can you describe the collaboration with the operators to deploy this system?
Absolutely. And, you know, as I mentioned previously, you know, before we start working with any particular operator, we'll have a few collaboration sessions where we define what these workflows are going to be in the valve sequencing to make sure that is you know, a robust process, and we're not going to ever expose the well to any unsafe conditions. And oftentimes through that collaboration process, we're actually able to provide our clients with insight to say, hey, if you switch this manual valve to a hydraulic valve, that might eliminate a lot of red zone trips and a lot of time on the pad, right? Or, you know, if you change the sequencing, that could, you know, speed things up a bit. So it kind of becomes a little bit of a consulting session on, you know, not just what's the standard work today, but, you know, what are the possibilities? How can we improve? And then we build it into the software, and, you know, we'll hand it off to the techs on location, and we're just following standard work. And you're actually operating your well as opposed to operating a bank of HPUs with duct tape and markers as your visualization tools, right? So a few other nice features. Sorry, go ahead.
No, I was going to say, and so this is a live system. This isn't something you guys are coming out with in the future. Like, this is something you guys are using to date in the field currently.
This has been in the field for more than 2 years now.
Wow.
Yes, sir.
Sorry, I know you were going to say something, then I was going to interrupt with a question, so go ahead.
Yeah, no worries. So just a few other nice features that we built into the software. So we have a e-kill or emergency shut-in. So if an emergency happens at the well site and you need to shut a particular well in and go deal with something that's more urgent than running out to an HPU and turning a bunch of levers, right? From the wireless tablet, you hit the e-kill and you're going to get a pop-up confirmation that, hey, are you sure you want to shut this well in? Once you confirm that's the action you want to take, every hydraulic valve on that well will begin to shut one at a time. And the order or the sequence that those valves close in is completely customizable in the same way that we customize the workflow. Additionally, if for any reason someone on the well site isn't happy with the way the workflow is working out, or maybe they decided to add another valve at the last minute and it changes the way they want to do the workflow, you can always come back to your home screen, go to view edit workflow, and we have another app within the app, so to speak, that allows you to look at your frac and your wireline workflows, and you simply pick the step or steps that you want to edit, change your expected states in your sequence, and come back to your home screen, and the workflow is automatically updated. We also provide an advanced mode. We recognize that there are circumstances where you need to get outside of standard work. Maybe there's a valve leaking and you're trying to chase where the leak's coming from, something like that. So you can go to advanced mode, and then from there you can just click on any valve to open or close. You will get a little bit of an additional warning each time you work in advanced mode, just reminding you you're stepping outside of standard work. Now, all this information you see gets logged, and it also is we're also able to stream this to the cloud. So any client, sitting in any office location can actually log in and see exactly what's happening at their well site with full traceability of every valve's open close movement. That means I'll know exactly what time I opened the upper master valve at the beginning of the frac stage and how long it took that valve to open and who opened that valve. So we have the operational context as well as the timestamp data tag for every valve on location. We also monitor our HPU system pressure coming into our digital enablement skid. So we use the HPUs to just send pressurized fluid to our skid. We always recommend running an auto start HPU to take advantage of the automation. Sometimes the auto start feature may not be working or whatever reason. You don't want to be waiting to open or close a valve because you try to open and you realize at that point your HPU pressure is low. So as soon as it goes low, you'll get a warning on the screen. You can have somebody run out and recharge the accumulator, investigate what's going on before it becomes on the critical path, right? Additionally, we deploy a sensor kit that is able to give positive confirmation when the wireline tool string is out of the well. So if you try to close a valve and the sensors haven't recognized that the tool string is safely out of the well, you're going to get a high risk warning, and it's going to tell you exactly why you're getting the high risk warning. It's going to tell you which signatures were found and which weren't, and a timestamp on those signatures. In addition to that, you can double click on our graphic right here in the upper left hand corner of the screen and get a histogram, so you can see the activity of all those sensors on a histogram. So what was the last activity on those sensors for the last 5 minutes, 10 minutes, 20 minutes. You can zoom in and out on the time scale. So effectively eliminating the possibility of unintentionally cutting wireline. This software actually also enforces the valves to always be fully open or fully closed. So you can't progress forward in the workflow until the valve reaches the full expected state. And that's to prevent a scenario where you think a valve is shut and it actually isn't. It's maybe only halfway shut. Or you think it's open, but maybe it's packed off with sand in the cavity, so the bore is sticking into the gate sticking into the bore by maybe a ½ inch. Well, if you pump through a valve like that at 100 barrels a minute, the valve's going to wash out pretty quickly. So the software is always looking out, making sure things are done safe in the right way, preventing a lot of lost time. There's many other safety features embedded in the software that are always ensuring safe operations and timely operations.
So my mind's still blown on the fact that, wireline could be cut out on a frac job. It's just something that's never crossed my mind, right? So let's say that you don't have Valve Commander out on location. How would an operator prevent that from happening?
Usually by, I've seen a lot of different attempts at it. So you can see signs hung. So somebody might go put a sign on the accumulator that's controlling the valves on the wireline run. But again, it's always subject to human error, right? Somebody may forget to move the sign when they're supposed to. The sign might be there, and somebody may just, sometimes we're working under duress or in extreme conditions, in the heat, the cold, and some maybe the sign gets ignored. So, at the end of the day, it's you can see having to go out there 50, 60 times a day and execute this at an HPU, how you might make one mistake out of 500 times, but that one mistake can cost the client millions of dollars. And to me, that's putting somebody in an unfair situation. We're not helping them to be in the best position to succeed until now.
So obviously you guys have done a lot of you've already done field trials. I'm guessing there are some case studies. What have y'all seen of some of the biggest benefits to the end consumer of being able to run the Valve Commander?
So one particular client I can think of, we are actually able to reduce their transition times by 35%. They actually started to change and evolve their workflows to do things a little bit differently. That's adding even more time benefits to their transition times. We've seen no valve failures since we started running with this client at the beginning of the year. And, I think that's attributable to the fact that we're always getting that tattletale when the valve's not open or closed. And I think it's underappreciated how often valves get fracked through when they're not fully open due to how much sand can pack off in the valve cavity. But unless you're always sending someone into the red zone to check that, it can get overlooked. And I think it happens often.
So now that you guys essentially started to be able to automate the most basic and analog function of opening and closing valves and being able to track what's open and what's closed, does this really start to open the door for automation? What comes next, from your perspective as a completion engineer?
Yep. So if we go back to the screen here, what we're going to be, what we have commercialized recently and we're getting ready to roll out en masse is our automated greasing system. So, you don't want to be in a scenario ever as a valve provider where the operation's waiting on you, right? Especially when the operation's waiting on a valve to be greased, but it happens all the time because valves require a lot of grease due to the environment that they have to work in. And the process can be cumbersome, especially when you start getting into cold weather ops. So we address this problem in a few different ways. One, we developed a grease injection skid that is actually hazardous location rated, so we can place that skid as close to the tree as possible, so we're not having to pump this viscous grease through a half-inch line of 200 or 300 feet, which can take a really long time. The whole system is totally remotely operable on the same software platform as Valve Commander. So what that's going to look like at deployment, you'll have a frac workflow, a wireline workflow, and a greasing workflow. So we put 2 high-pressure pumps on this skid, so that allows you to operate it in a few different ways. You can have both pumps running at the same time into the same injection port to speed that up. You can grease into 2 different injection ports at the same time, or you can run 1 pump at a time and use the second one as a backup. From the HMI, that allows you to remotely start and stop each pump. It's actually measuring the amount of grease that you're using on each instance. And you can actually now see inside of the valve cavity in effect because we're tracking the valve cavity pressure. And you can see what it looks like, and it's quite repeatable when you grease a valve, right? When you pump into an empty cavity and build pressure up in that cavity and then displace grease to the other side. So with a process that's so repeatable, that's prime for automation, right? So our objective is to have a maintenance system that's totally automated. So, in the future, you'll have someone open and closing valves. The automation sequence is going to be running in the background.
I know working on the service side, the operator doesn't always come up to you and say, "Hey, good job, way to go." But what's been some of the feedback from clients who have been able to implement these systems?
It's been met with a lot of positive response, and I think what's really kind of neat about this is how quickly we can go from such a manual analog operation to we deploy this, and then all of a sudden, our clients are really smart, and the people that work for them are really smart, so they're always coming up with new ideas and new features how to make it even better. So as soon as we start deploying, there's this immediate, kind of further collaboration on, hey, I'd like to see this feature or that feature. I'd like to see this on the screen. So, I guess the exciting part is that we're really just scratching the surface with what we can do here.
Awesome. So I want to wrap up with this. Obviously SPE has the hydraulic fracturing technology conference. Sorry, it's a mouthful since I don't usually say that. I'm always doing the drilling stuff. What are you looking forward to from the conference that's coming up? What are you most likely looking to be able to see?
So I've been with this company since we really first started asking ourselves, what does the digital oil field mean to us? And, now I'm sitting here and having these tech talks about all these great things that we've accomplished. So for me, I'm excited and looking forward to seeing what other applications and what other values being driven by some of these digital technologies.
Excellent. And so if anybody's interested in learning more about the Valve Commander, who do they get in touch with and who should they talk to?
So you can definitely reach out to me. I believe we're going to send out some communications after this tech talk with my contact information. You can go to slb.com/Valve Commander. And you can reach out through any of our sales channels.
So one last question for you, because we still got a little bit of time, and this is what I wanted to be able to ask earlier. Do you think in the future that there will be the KPI of like number of incorrectly closed valves? And because like on the drilling side, we talk about, mean time between failure, mean time between, having to trip out a hole. So like on the frac side, could it be something like the number of times that you or how long you've gone without an incident? Is this really opening the door to be able to start bragging about saying, hey, look, we haven't had an incident in over 3 years with the Valve Commander?
Absolutely. It's the beginning of almost the gamification of these types of operations, right? And again, because you've got all this data tracking everything now that's happening at the well site, it's just a matter of a week or two of programming to start developing these these KPI dashboards that are being tracked in real time. And again, I think we're really just scratching the surface on what the possibilities are with this.
So is this really the beginning of getting true digital data on the frac side?
Yes, sir. And we also have plans to expand to not just acquire data coming off of the valves and the wellhead, but also data coming out of the frac side, data coming out of the wireline side, to be able to give the end user one place to go to be able to see the entire operation, as well as tying all those data strings together and using machine learning and other techniques to give recommendation engines and orchestration and tracking KPIs, these types of things, right?
I mean, this is such a big difference to be able to go from just hanging a sign on the frac tree to being able to look at everything digitally on an iPad. Definitely setting it up to where my kids could be able to run the frac operation. So that's really exciting. Tony, any last words for everybody out there that's watching?
Just thanks everyone for your time and attention today. And if you have any questions about the product, please reach out. I'm always happy to talk about it. Quite enthusiastic about it. Can't tell. And again, appreciate you guys having me on today.
Well, thank you so much for being here and being able to at least educate me on what's happening after we get done drilling the well. I've never been out there, and it's still one of those things where I really have no idea what's going on. I just knew at the beginning of this that there were a whole bunch of valves, right? So thank you so much for being here. Everybody that's watching, please reach out to Tony. He is on LinkedIn. Reach out to Tony on LinkedIn. Get in touch with him. As well as if you are interested in finding out more, go to the Schlumberger website. The link should be in the description. If not, we'll probably get it in there in just a minute, right? As well, be ready for the make sure I get this right, Hydraulic Fracturing Technology Conference that's coming up. We hope to see you there and take place. It's from the 4th to the 6th of May. And as well, be sure to stay tuned for future SPE talks that will be coming up in the near future, other SPE lives, and get involved in your local SPE group, get involved with the industry, give back, and enjoy. So, Tony, once again, thank you so much for being here. We learned a ton. And until next time, guys, see you on the next one.
Yes, sir. Thank you.
I think anybody that's in the industry that works in the area of hydraulic fracturing would gain a lot from this particular conference.
This conference is the premier event worldwide where completion, stimulation, and reservoir engineers can find the latest advances in fracturing technologies and best practices for completion designs.
Those who attend the conference are generally engineers, geologists, and those in academia focused in hydraulic fracturing.
This conference is one of the few that SPE has that specifically focuses on one topic, and all of the experts, all of the people that work in this particular area are there. And this is where we find and understand the newest technologies that are coming out.
This year's conference will be virtual.
All these sessions are recorded, so you can go back and review the technical content,
ensuring you won't miss technical presentations that would normally be in competing sessions in in-person events.
It's much lower cost than in person. And there will still be networking opportunities and an opportunity to see people that you might not have seen for a long time.
An important benefit of attending SPE conferences is maintaining and building your network of industry contacts. There will be a new kind of online networking to facilitate informal discussions and networking so we can stay connected to our colleagues around the world.
COVID-19 has impacted us greatly. However, these virtual events has kept us connected all around the world. By attending these virtual conferences, such as a hydraulic fracturing technology conference, we can overcome this.
So I'd encourage anybody that has the opportunity to join us at HFTC and see what you can learn from it.
In hydraulic fracturing operations, the fracturing fluid is delivered from the missile trailer through the zipper manifold to the frac tree and into the well. In complex multi-well fracturing, wireline and fracturing crews constantly alternate operations among the wells to isolate a well and rig up wireline, or to open a well and pump fracturing fluid to stimulate the formation. Opening and closing valves on the frac tree and manifold must be carried out accurately and in sequence. Conventionally, this requires manual operation of a lever on the hydraulic power unit. This manual intensive activity creates an operational risk due to the potential for human error. Functioning the wrong valve at the wrong time can cause non-productive time, add costs, damage equipment, and increase other safety risks. Cameron Valve Commander Automated Control and Advisory Platform enables the industry's first remotely operated frac tree. Operators can instantly control frac valves with the click of a button and monitor the position of the valves in real time. Visual cues indicate which valves are open and which are closed. The software digitizes the standard workflow of the fluid delivery system, and the advisor offers step-by-step guidance of valve sequence, reducing risk of improper valve operation. On the touchscreen, the operator selects the valve to operate. A signal is sent to the digitally enabled skid, which then diverts fluid from the hydraulic power unit to the chosen valve to open or close it. Cameron Valve Commander Platform improves efficiency and performance by enabling operators to verify valve position in real time, mitigate overpressuring valves, eliminate cut wireline, remove workers from the high-pressure zone, digitize a standard workflow to prevent incorrect sequencing, and increase stages per day by more than 10%.